Worship of Cheryl Lau and Claire Seeger, and my project is comparing two angiogenic therapies for promotion of tissue repair and treatment of cardiovascular diseases. The Bochway Lab takes a multidisciplinary approach towards improving tissue engineering therapies by studying microvascular networks and inflammation, which is the body's natural response to injury. It comes from trying to treat a process which is very harmful to the body and can lead up to strokes and different things. And or sphingolipid therapeutics. When I refer to macrophage soluble factors, I was referring to macrophages, and basically there are cells that do immunity, muscle regeneration, wound healing, and there are 3 different types of macrophages. The M0 macrophage is at a resting function. There's no specific function attached to it, whereas M1 macrophages are the inflammatory macrophages, and they have roles in mediating defense against bacteria. And you have the M2 macrophages, which are the anti-inflammatory macrophages, and they're known to regulate tissue repair. And that's why I'm referring to the macrophage soluble factors and the sphingolipid therapeutics. And when referring to the sphingolipid therapeutics, can a small molecule drug recapitulate the effects that macrophage soluble factors have on angiogenesis and modulating? And the real world application is activating the normal and vital process of angiogenesis to help solve atherosclerosis or any ischemic diseases. This slide here basically shows my methods. I culture endothelial cells, HUVECs, and I also culture monocytes, which macrophages differentiate from. And I differentiate it to have the M0 macrophages, and I polarize the macrophages to have the M1 and the M2 for the different match the phenotype. And then I performed a matrix gel assay, a 3D angiogenesis assay, and this is how the images look using the macrophage soluble factors, which is the conditioned media, and FTY720. Preliminary data between a 48 and 24-hour time point. When comparing, it's similar to a fold change analysis, but when subtracting the lengths after 48 from the lengths after 24 hours, the only one to increase over time was the networks and M2 condition media. When talking about recapitulating the effects, this is the FTY720, a small molecule drug. It's known to perform an immunomodulation, and it's an agonist of S1P receptor. And when the matrix gel assay, this is how the images look. I did 2 different concentrations, 4 nanomolar and 12.5 nanomolar, to see whether they're dose dependent or need to be at an optimal concentration. And my data, networks and FTY720 wells occupy more total area than the control wells after 24 hours, but less total area than the control networks after 48 hours. And it's basically showing that FTY720 does impact the growth or the network formation of HUVECs. And this is the images at the 12.5 nanomolar concentration. And networks and FTY720 wells occupy less total area than the networks and control wells after both 24 hours and 48 hours. And in conclusion, macrophage conditioned media and FTY720 independently modulates angiogenesis. So now we were wondering, can these 2 strategies effectively be combined to modulate angiogenesis? And understanding the cues that promote endothelial network growth can guide the design for future pro-angiogenic therapies for many different applications.
Mr. Amadou Bah, any questions?
Yeah, this is very nice. So why do you think they fell apart after 48 hours?
Comment on if these networks were formed due to cellular migration or cellular proliferation.
It was performed through cellular proliferation. And even within the lab sometimes when talking about cellular migration, some stem cells or other cells are known to migrate. And actually in future direction, I'm working on cytokines that are known to be secreted by the conditioned media and known for cell proliferation.
Well, very good.